G'day and welcome to the second video of continuous random variables. We're looking at probability density functions, or PDFs, and we've got this situation where we've got a fire drill that's going to happen at some point in our class, and we don't know when, but we know that the function is defines the time in our class, and the area underneath the function will actually give us some probabilities of things happening. So the function is 3x squared multiplied by 100 minus x all over 25 million. Sorry, 25 million, I guess. Big number. So now we've got this function. We know that the conditions are met for PDFs, so that it's all above the x-axis, and it's the area between the two boundaries is equal to 1. We can now use this function to determine when the fire drill will actually be. However, with continuous random variables, you can't determine the exact time something will occur. Instead, you can only determine the probability of something happening within a range of values. Okay, and then this is due to the fact that you can't actually pinpoint a particular time. So, you know, is it 17 minutes, or is it 17 minutes and 1 microsecond, or, you know, did the fire drill happen at 15 minutes or 14 minutes and 0.9999999 minutes? Like, it gets a bit tricky. So we can only work it out within a range. So, for example, the probability that x equals 17 happens at the 17th minute, that's equal to 0. You can't actually get the area of that. But what I can do is I can work out the probability of it happening within the first 17 minutes. Now, with continuous random variables, it doesn't matter whether you've got an equal sign underneath the less than or the more than sign. It makes no difference. Both of these two will give you the same answer. And the way that we get this answer is we simply integrate between 0 and 17 for this function. So I might even write this down: between 0 and 17 f of x dx, and that, if I just flick to my calculator, that should be equal to 0 and 17 of f of x. That, which is nice, I'll just get it in a decimal so it's a bit easier, 0.017. Okay, 0.017. It's all a little bit squished in there. And this is the same, so 0.0. I'm going to rub it out. Start again. 0.017. Okay, so close to a 2% chance of happening in the first 17 minutes. So not a high chance, which is nice. To find the probability of the event occurring within the range, we integrate between the two terminals, as I've just shown you. So, question 1, and we're going to find all of the answers correct to 4 decimal places, not 14 decimal places. That'd be crazy. Find the probability of the fire drill happening before the first 10 minutes. I guess this is fairly similar to what we had before. I actually made a mistake here. The second mistake, that's not so good. If it's before the first 10 minutes, then that has to be facing that way. Okay, so in the exam, what I'd write is I'd probably write this bit here, and then I'd say that equals the integration between 0 and 10 of f of x. So let's do that. Let's find out what this is. I'll push control equals because it says 4 decimal places, 0.0037. Okay. The probability of the fire drill happening in the last 15 minutes, well, that's just this, x is between 85 and 100. That's just an integration between 85 and 100 of f of x. So again, I do this, and I'm going to go to 100 and 85, and control equals, because 4 decimal places, 0.1095. 0.1095, is that right? Yeah, 1095. So you can see that that's actually about 11% really. So it's a much higher chance happening in the last 15 minutes than the first 10 minutes. Now, as we have some important material to get through today in this little video, I've asked that if the fire drill can be after the first hour. And the people in Power, they've taken my request on, so we know that has happened. What's the probability that the fire drill will happen in the last 15 minutes of class? Now, there's a little trick to this question. This is actually a given probability question, and hopefully we remember given probability from year 11. because we know that they've taken on my request, they won't put it in the first hour. We can actually eliminate all of the the first hour from our probability distribution. So we can actually write this. We can say that given this line here means given that it's happened in the first hour, so after the first hour I should say, so x is greater than 60. What's the probability that it will happen between 85 and 100? So essentially what we've done, before I get into the actual working this out, here's my function and what it looks like. We're saying that it hasn't happened in the first 60 minutes, so I'm just going to eliminate all of that. That's now gone. What I want to do is I want to find out the probability of this happening, between 85 and 100, so between there and there. What's the probability of that happening now with respect to this, not respect to the whole thing? Before, with respect to the whole thing, it was actually 0.1095, but in this case, it's going to be something different from that. It's going to be a higher percentage than this because we're actually only comparing it from 60 onwards now. We've eliminated all the other points. So mathematically, the way to do that is to get this, to understand what's going on here. Remembering, and I might just write this down. Remembering the given probability formula is A given B. That equals the probability of A and B together over the probability of B. Okay, I actually covered this slightly in another video. I think it's background information for discrete random variables. You can go and watch that if you'd like to just touch up on a few of their probability things. So applying this formula, when probability that x is between 85 and 100, and it's also greater than 60. So the question is, I need to know when those two things happen at the same time. Now I like to use a number line for this. So I like to say, okay, and I might even do it down here. I'll say, when is it between 85 and 100? Like if I do a number line here and say that's 50, this is 85, and that's 100. So I'm looking at that bit just there, between here and here. And then also x is greater than 60. Well, that's from, in a different color. That's from 60 onwards. Ooh, that wasn't a different color at all, was it? 60 onwards. Terrible one. When do those two things the same? Well, it's actually going to be between 85 and 100. Okay, so the probability 85 and 100 divided by the probability that x is greater than 60. Now I've already done x is between 85 and 100, and now I just need to do this between 60 and 100, and I'm going to do, I'll find out what that is actually, and then I need to do this answer divided by this answer, and hopefully I get a nice answer of 0.2087, we'll say that. So that's 0.2087. Okay, so as you can see, it's a higher probability than the previous one because now we've eliminated a whole bunch of things. So this is how to do a conditional probability for this question. In the next video, I will have a look at a couple of other things like expected time and all those sorts of things. So thanks for watching.